So today we will be solving LeetCode 2448, that is minimum cost to make array equals. So we are given with two zero indexed array, that is nums and cost, consisting each of n positive integers, and we are provided with a condition, that is we can do following operations any number of times. What is the operation? We can increase or decrease any element of the array nums by 1. The cost of doing these operations will be operations on the ith element is equivalent to cost of I, that is cost array of that particular index. And we have to return the minimum total cost such that all the elements of the array nums becomes equal. Okay, so we are given nums and we are given cost, and this is the output which is being calculated when they try to turn all the elements equal to 2. So how we can solve this particular question? Let's see. So this is the array nums and cost, and now let's try to change the array nums equal to 1. So for that, what all operations we can perform? So firstly, I will come up to this place, first element. I will check is there any requirement for adding or subtracting any values. So no, because this is already equivalent to our element. Then we will proceed to next number, that is 3, and we can see we have to subtract 1 from 3 twice in order to make it equal to 1. So the number of operations will be 2 and the cost for this is 3. We can see at this place. So we will multiply it by 3. Fine. Now we will again proceed and we are at 5 now. So at this place we will be performing 4 operations, that is we will be subtracting 1 from 5 4 times in order to make it equal, and then again we will check the cost, we will multiply in the number of operations, again we will proceed and we will check is there any requirement for operation. So yes, one operation is required, we will subtract 1 and multiply by cost. So this will become 24. The same procedure we will perform for all the elements, that is for 3, for 5 and 2. So for 3 it will be 20, for 5 it will be something around 56, and for 2 we know that it's 8. You already saw it in the example. So we did this whole process in big O of n square time. This is a sort of brute force approach where for each and every element we are checking all the n elements and then calculating the cost and then returning the minimum cost. So can we do better than this approach? Then the answer will be yes. But there is a slightly different approach for this. So let me just clean this up and we will go through that procedure. So if we try to visualize this whole solution, the values that we got from this solution on a graph, we can see very clearly that at 1 we are getting 24, something around here, and then at 3 we are getting 20, and for 5, let's assume 5 is here, we are getting 56, and for 2 we are getting 8. So if we are going to join these points, we can see this is a sort of convex graph, or we can say that our cost function is a sort of convex function. So now we know that our cost function is a convex function, not a kind of. Then how we can utilize this information in order to optimize a solution? So we can see that when we are at this step, we can see the value is 24. Right now we can't make any decision like we should proceed in right direction or left direction, but when we are at 3, we can see that 5 is larger, 5 is having higher cost than what we calculated at 3, right? We calculated cost at 5 and it is equivalent to 56, which is greater than the cost at 3. So we know that we should move in this direction, in left direction. Then only we are going to find our answer. We realize that this whole problem is somewhat similar to one of the algorithms that we had, and that is binary search algorithm, where there is a left pointer, there is a right pointer, and then we try to calculate a mid, which is our answer. So we will be solving this whole problem with binary search algorithm. Now how we are going to solve this whole solution with that approach, that is something we will see in a minute. Let me just clean this whole screen so we can visualize that solution, that whole explanation. Okay. So now, as we know, for binary search, the first requirement is to find the pointers, that is left and right pointer. So if we are going to see this whole array, one thing is clear to us, that is if we are going to choose any one of the elements from this existing nums array, then there will always be a possibility that any one of the test case is going to have 0 operations. That we already saw in the previous brute force approach, that when we were choosing 1, at 1 we were having 0 operations, then for 3 as well it was same. So for that reason we can assume that the minimum or the leftmost pointer can be kept as minimum of this array, because then only we will be able to have the optimal search, right? So our left pointer will be nothing, it will be minimum of the nums, and that is in this case equal to 1. And so for our right pointer we will do the same. We will take the maximum of our nums array, because if we are going to consider greater value than 5, suppose 6 or 8 or anything else, then we know that the number of operations are also going to be increased with the increasing numbers. We can't assume any case that in which we are going to get the number of operations reducing. With the increasing numbers, the number of operations will also increase. So we won't be considering numbers greater than the largest number in the nums. So for right pointer we will take the max of nums, in this case it is 5. So now we are having our left and right pointer. So we will calculate our mid, which is nothing but just left plus right divided by 2. But in this binary search there will be a slight change. And why we are having that change? Because we are not having those left and right pointer sorted, right? Because we are not performing binary search on 1, 3, 5 or 2, but we are performing binary search on the cost that we are calculating on these elements using like when we are trying to transform the whole array in calculating the cost. Therefore we will not only assume mid, we will also consider one more pointer, and that will be mid plus 1. Why? As we already saw, there were 2 points 3 and 5 in the previous drawing. We saw that after comparison we realized that we have to move in left direction. If there won't be 2 pointers, then how we are going to make this decision? Because on the basis of mid value we can't make this decision. We have to make this decision on the basis of the cost that we calculated. So we will calculate cost not only for mid value but for mid plus 1 as well, and then depending on that we will check if cost 1 is greater than cost 2. In that case our left will be mid plus 1, else our right pointer will become mid, or mid's value is assigned to right pointer. So this is the whole explanation how we are going to solve this particular question. So for this question itself, this is the first step where we will be having left equal to 1, right equal to 5 and mid equals to something that we are going to calculate. So our left pointer is 1, right is 5 mid will be 5 plus 1, 6 by 2, so it will be 3, and mid plus 1 will be 4. We will try to calculate the cost for 3 and 4, and then we will see that we have to go to left or right. After calculating this, as I already calculated for 3, so I know the cost of 3 is 30 and cost of 4 will be something greater than 30 and lesser than 5. We know that. So as we know, we want to calculate the minimum value, so we will go to left direction, right? I'm not calculating the cost of 4. I'm just applying the common sense there. Right pointer is going to be updated because our left pointer is at right place and our cost is lesser. If the cost would be greater, cost 1 will be greater, then we will be updating our left pointer. Right now we will be updating our right pointer and it will become equivalent to mid. So now right is 3. We know that when we are changing left and right, we are again going to update our mid. So again mid will become 2 and mid plus 1 will become 3, and cost of 2 we know it's 8, and mid plus 1 is 20. Oh, I wrote 30 previously, my bad. So this is 20. We know that 8 is lesser than 20, so again our right pointer is going to be updated. Left is 1, right is going to be equivalent to mid, and mid will be equivalent to 1, and mid plus 1 will be equivalent to 2. Now we are again going to calculate for mid equals to 1, and that we know already it's for 24. In this case it will be 24, and 24 is greater than 8, so our left pointer is going to be updated. Left will be equivalent to mid plus 1, so that is 2, and now as our left is not lesser than right, so we don't have to proceed in binary search. We will return the answer as left pointer and the cost associated with it, that is 8. So we will return 8. So this whole algorithm runs in log k time, log k for binary search. And as we are also calculating this cost, for that we will take big O of log n, big O of n. So in total our time complexity will be big O of n log k, where n is the number of elements in num and k is the difference in the maximum and the minimum value of elements in num. So this was the whole time complexity, and space complexity will be big O of 1. So now let's code this whole solution and we'll see the output. So I've already coded this small function, that is get cost, in which we are doing simply calculating the cost and nothing else. We are zipping num and cost array and calculating the cost on the basis of the value that we are going to pass in this function. We are going to pass mid and mid plus 1. So we will be calling this twice. Okay, so now let's code our binary search part, where firstly we want left and right pointers, and they are, we already know, min of nums and max of nums. Okay, what happened to this comma? Then we are going to define a variable which will be storing our cost. So for now let's store a cost for the first element, and now we will start our loop. That is, this loop will run to the point when left pointer is less than right pointer. Firstly we will calculate our mid now. So mid is left plus right divided by 2. Then we will calculate the cost 1, which is get cost, and we will pass our mid value. Then we will calculate cost 2 because we need to compare both the cost, and then we will decide in which direction we need to proceed. So this is mid plus 1, and then answer will be updated depending on the values that we received. So that is cost 1 or cost 2. We will keep the minimum value. Now we will check if cost 1 is greater than cost 2, then we have to update our left pointer, and that will be equivalent to mid plus 1. And if this is not the case, then we will update our right pointer and make it equal to mid. At the end, we will return our answer. So this was the whole code, and let's try to run this code. Okay, I did something wrong. Okay, I did answer minus. That's a typo. Okay, now it's working. So we can see that this solution is very efficient, 41.18%, and I don't believe on these percentages, but still it's efficient. And if you like this whole video, then you can press like button, and I will see you soon with a new video. Thanks for watching.